Welcome back to Let's Code. Today I want to take a short introductory look at the builder pattern in Rust. And when I think of the builder pattern, the first use case that I think of, or the first module that I think of that happens to be in the Rust standard library, is the command struct. So let's scroll down a little bit here. This is how you use the command struct. Let's ignore everything except for this right in here. So ignore the if statements, whatever. And actually, let's talk about the bottom one instead, because I think that'll be a little bit easier. So the command struct is a builder, or what we term in the Rust ecosystem, a builder. The idea here is that we want to run a process, or in other situations, we want to configure something. That thing will often have some fields that are required and many which are not required. So for example, to run a new process, we have to run something, right? So command new will take whatever that base thing is that we need to run, whatever program we're running. And then we can pass in arguments optionally afterwards using .arg. And the concept here is as we build up this command struct, we then get to also choose how it's finalized. And it finalizes into something else, something that isn't command. So in this case, we're building a new command. We add some arguments, and then we say, run this and give us the output. Give us whatever this command did, give that back to us as a string. And that function actually returns a result, so we expect it. And if this is a error, then we'll panic here with this message. And if it succeeds, then we'll just continue like nothing happened. Or actually, in this example, we store the output in output, the variable up here. So let's take a look at new. Before we go look at new, I want to show off what this command looks like on the command line. So we could do something like this, sh-c echo hello, and we get hello. And this is because we're running sh. Sh is going to pop us into a different shell. And then -c allows us to pass in a command to run inside of that shell. So it's the same thing as if we hit sh and then we type echo hello, which might make more sense to you if you're used to working on the command line. So you can see here that we've specified sh as the thing we're going to run, -c as the first argument, and echo hello as the second argument. If we scroll down here, we can see that command new is an associated function on the command struct, takes some OS string, so something like sh, or basically we can access anything from our path variable, anything like that. So we have to give it some program to run. And this is pretty common in builder APIs. When you do new, or you do whatever the equivalent of initializing one of these builders is, you have to give it the required pieces or the required fields. And then everything that's optional will come after that. So this new function returns a command that should seem pretty regular to you if you have been using Rust for a while. We have a lot of new functions in Rust. But note that this creates a new command and sets a number of default configurations. But those default configurations aren't fields we can access. Like, we don't know what they are. They're private. And if we go look at the source code, there's a whole thing going on here. But we don't really care about any of that. All we care about is that we can construct a command with this new function. It gives us some defaults for our process, which are held as fields on this struct. We can then optionally use the arg function to add more arguments or other functions as well, not just arg. But notice that it always returns a command. And that's really what powers this builder chaining API. So if you see that we have command new, then we could do .arg -c, which returns a command. And we can do .arg and then another argument, which returns a command. And then we could just keep chaining that together over and over because it's always returning command. In this case, it's returning a mutable reference to a command, but we'll glaze over that for now. There are a whole bunch of other functions as well. We can set an environment variable, for example. There's some key that we have to set, so some environment variable name and the value of that environment variable. So we can do .env path/bin. And then when we spawn this process, ls will run for this path. And some get pretty complicated, right? So you can do things like remove a specific environment variable. So maybe you added one and then you remove it later. You realized you didn't need it or something like that. But this is all part of the kind of building up of this command struct. So we've got command new, which gives us our initial command struct. We've got all of these other configuration functions in the meantime that we can use to configure different fields in different ways. And all of these chain together, by the way. We can just keep chaining them, keep chaining them, keep chaining them. And then we end up with the finalizer functions, or what you can think of as the finalizer functions. Basically, the thing that turns a command, which we've built up, hopefully into a working program, into some other struct. So spawn doesn't return a command like all the other .arg and .env do. It returns a result child. And child has standard in, standard out, and standard error, all of the outputs that would come out of running a command on the command line. Similarly, output returns a result output, and output has the exit status and the standard out and the standard error. So depending on what we actually want back, depending on how we want to execute this, we can choose from one of many different finalizer functions. Here's another one called status, where it takes a mutable reference to self, so a mutable reference to the command that we're building up, which is the same thing that .arg returns. So we've got a new command, we get the mutable reference from arg, we hit status, which is the finalizer, and then we get a result exit status. So it's either going to give us the exit status if it was successful, or it's going to error out, in which case here we're using expect, which will panic. But we could also use the question mark to handle it or whatever. So that's the fundamental idea of the builder pattern. You start off with a struct with some new function or some initializer function. You have a bunch of other functions that keep returning that struct back, which allows you to keep chaining more functions on the end and configure that struct. And finally, when you're ready, you can just say, I'm done, do something with this. And you'll either have one or many options to choose from as a finalizer, but that's basically the way it'll work. Here's a pretty popular library called request. And this is a HTTP request library, so you can imagine there's an absolute ton of configuration that you could possibly do to one of these requests. You could set HTTP headers, you could set the URL, you can set the body of the request, all sorts of things like that. So in this case, if you do client.post, that will initialize you this new builder function. You can set the body of the request. In this case, you set it to some text. And then you finalize it with send, which returns you back a future that you can await. So if we go and we look at the post function, we can see that it takes a URL because, you have to make a request to a URL if you're going to make an HTTP request, and it returns this request builder. And if we click on the request builder, we can see, again, it's got a bunch of private fields. This isn't a struct that we're supposed to see into. It's something that we're supposed to use to call these functions on to build up the configuration for. And there's everything here that you would expect to have. There's headers, if you want to set multiple of them. You can set basic auth, which you probably shouldn't, but is technically part of HTTP. And then we can see that send, the finalizer function here, returns us a future with an output of result, response, error. So if it's successful, after we await it, because a future is awaitable, then we'll either get the response, like an OK response, or an error. And this pattern just pops up all over the place. So I'll leave it at those two examples. I think I've gone over enough to introduce the concept to you. And now, hopefully, when you see something that is a long set of chained functions that starts with new and ends with send or something like that, you'll understand that you're seeing basically a dynamic configuration being built up and then finalized. Have a great day, and I'll see you in the next video.